So let's do some examples of determining whether a molecule is aromatic or not. And let's write up our rules over here. Huckel's rules. 1, we got to have a ring. 2, I'm just going to say atoms need to be sp2 hybridized. That is not exactly what the rule is, but that's what I'm going to write because that's what it boils down to. Needs to be flat. And lastly, we need to satisfy this 4n plus 2 rule. Okay, great. And that is essentially we need 2, 6, 10 electrons. And if you keep that series going, it could be 14, but that's starting to get a little bit bigger than we normally encounter. Okay, we already looked at benzene. And that is the poster child for aromatic compounds. Let's look at a different molecule. So that's benzene. Let's look at toluene. Is toluene aromatic? Now, toluene is kind of a trivial example because the fact is it contains a benzene ring. So you think, well, obviously that must be aromatic. However, this methyl group, which we've drawn out so nicely, that doesn't have any p orbitals. That's not part of a ring. It's not flat. It doesn't really fit with Huckel's rules. Well, as it turns out, yes, toluene is aromatic. Toluene is aromatic not because it has the methyl group or it doesn't have the methyl group. It's aromatic because this part of it is aromatic. This benzene ring is aromatic. So an entire molecule doesn't have to be every atom in a ring or sp2 hybridized or flat or have the right number of electrons. You can have non-aromatic pieces coming off of a molecule, and the molecule can still itself be aromatic. So this could be a methyl group, it could be an ethyl group, it could be another complete ring. So this would be cyclohexyl benzene. That's aromatic too, okay? Because part of it is aromatic. So if part of the molecule is aromatic, we will still refer to it as an aromatic molecule. Pieces may not be aromatic, but we'd still say it's an aromatic compound. It contains an aromatic ring. So that's what we're looking for. Okay, so anything with a benzene ring is going to be aromatic. Now how about this structure? This is pyridine. The real question in pyridine is, what do I do with this lone pair? Okay, because it kind of looks like benzene. It has 3 pi bonds, and those 3 pi bonds are great. This could easily have 6 pi electrons. It's a ring. All the atoms can be sp2 hybridized. It's flat, and it has the right number of electrons. It could have 6, unless we have to count this lone pair. If we have to count the lone pair, then we're 8 and we're not aromatic. Well, let's go back to the hybridization question. What is the hybridization of this nitrogen? If you go through the rules, you will find that this is indeed an sp2 hybridized nitrogen. So let's try to draw this structure, kind of draw it edge on. So we're drawing it flat, kind of perpendicular to the plane of the paper. And here we have our structure. So there's a pi bond, there's a pi bond, there's a pi bond. Where is this lone pair? If this lone pair is not part of the p orbital, remember these are electrons in p orbitals. If this lone pair is not in the p orbital, then we're fine. Well, as it turns out, it's sp2 hybridized. This lone pair is in an sp2 hybrid orbital. And it sticks out perpendicular. Remember, it's sp2. We're going to have approximate angles between these different sp2 orbitals of about 120. But there is a p orbital on this nitrogen, and it lines up with an adjacent carbon p orbital, and that makes a pi bond. Well, once this nitrogen uses its p orbital to make a pi bond, it can't use that p orbital to also hold a lone pair. So that p orbital can only do one thing, make a pi bond or hold a lone pair. We've committed to the pi bond, not the lone pair. Therefore, this is fine. We have 2 electrons in this pi bond, 2 electrons in there, 2 electrons in there. This is 6 electrons. Pyridine is aromatic. You say, well, what do I do with that lone pair? Well, it doesn't matter. It's not part of it's not in the p orbital system. So clearly that lone pair does something, and in fact it acts as a basic lone pair, but it is not part of the aromaticity count. So it's kind of outside the scope of our discussion of whether pyridine is aromatic or not. So that's one example, very common. You need to handle nitrogens with lone pairs, and we'll see also examples of oxygen and even sulfur with lone pairs. We'll have to think about how to accommodate them in this aromaticity picture, and it all comes back to how do you handle it from a hybridization perspective.